Everybody to the Horizontal Curve Assessment webinar. My name is Jay McComb and I am Vice President with Quality Counts. And co-presenting with me today is Pablo Elvira, who is our GIS and development specialist and has done a great job creating a platform specifically for the assessment of curves. In addition to using the CARS developed by Rieker. So the whole purpose in doing horizontal assessments, the feds have identified there's 30,000 fatalities annually in the US. 50% of those are single roadway departures, and 50% of those roadway departures happen on horizontal curves. That means 28% of US traffic fatalities happen at horizontal curves. And 44% of accidents can be avoided by proper signage and striping, which is the least expensive countermeasures that you can do for accidents. The 2009 MUTCD mandated that all curves must be reassessed by the end of 2019. Creating a universal standard is very important in making sure that the driving public all knows that everything is universal and works properly. Replace all improper signage. There's a lot of signs on curves that aren't correct, particularly recommended advisory speeds. And there is a new chevron requirement that requires having the radius of a curve when you do it. So just ball banking isn't sufficient anymore. So Quality Counts does horizontal curve assessments better, cheaper, faster, and safer than anyone else. We've been involved in surveying over 85,000 centerline miles in 9 states over the last 5 years. We processed more than 200,000 curves, and we've inventoried now it's over 500,000 signs. We have had 4 statewide contracts. Our first one was in Ohio. We're wrapping up right now Kentucky, New York, and South Carolina. In addition, we've done a couple of the districts in California, as well as a couple of the regions in the state of Washington. So there's pain points for anybody attempting to do horizontal curve assessments. The first one is really project management. Who's responsible for getting it done? The next one, which is probably the easiest for a DIY, is the data collection. There's a lot of route planning. There's a lot of coordinating of drivers to collect the data. And if you're using the CARS system, which we highly recommend you would if you're doing it yourself, but if you're doing ball banking, then you need to have 2 people in the car. And then you also have to do some measurements of the curve to get the radius. Then there's curve processing. Even the CARS system has curve processing that's very important to do. And that is a big pain point that we have found multiple clients have. So we can help in that area. Sign inventories, lots of states don't even know what signs they have at horizontal curves. And the last is the cost. Even doing it in-house can be very expensive, particularly if you're requiring 2 people to be in the car at a time. The data collection, the route planning, the curve processing, processing of the data, the sign inventory is, like I said, very difficult. So there's a lot involved in doing it. And our process is, as I said before, we use the CARS system, which was developed by Rieker Inc. And it is a very robust system that we have worked with for not all 85,000, but 84,000 the centerline miles we've done. And our process is pretty simple. When we go in, we hire and train folks in a state. We try to hire local drivers, which reduces on having overnight stays and travel expenses. We create a hub and then we prepare that hub. Data collection, the drivers go out and collect the data per the route planning that we do. Then there's data upload, which is very important to make sure the data is uploaded. The data processing of the curves, and then the deliverable generation. So on the road, there's route assignments, which is very, like I said before, is time consuming, but very important to not have your drivers spending a lot of time driving on routes that aren't necessary, or in reducing the deadhead, both going out to a starting point and at the end point. We drive each route twice. That is recommended per Rieker, to drive each route twice in each direction. So it's actually 4 passes on every curve. There is equipment check and calibration, which we do. There's the raw data upload, which we talked about just a minute ago. And then there's the SD cards. If we are doing a sign inventory at the same time, we use a system where we videotape as we drive and then post reduce those signs as we go. And the post reduction will provide a detailed inventory of all the signs that are associated with curves. And in some cases, in the state of Kentucky, we're inventorying all the signs for the state system. Curve processing is fairly straightforward, but again, requires time and expertise. And the first part of it is selecting a curve. So in this example, we're going to use this curve right here. You determine if a curve is actually needed. And in this case, obviously it is. So we cast a net over the curve. Casting net essentially means we create a PT and a PC. And in doing that, that gives us the radius of the curve. Then that data is processed in the CARS portal, and all the geometry that's needed to have the proper advisory speed, have the sign placements, is calculated for you. So I'm going to turn it over now to Pablo Elvira, and he's going to discuss our HCA platform.
All right. Hi, everybody. My name is Pablo Elvira. I've been working on systems in support of these HCA projects for a few years now, and I'll just walk you through what we have discovered along the way. So HCA platform is the term that we use to describe the set of tools and workflows that we have developed that can be generalized to any HCA project. The basic flow is that they publish special interfaces using Esri and Google services, which our processors can use in addition to the analytical tools to perform the analysis more efficiently. All of that data is uploaded to Dropbox Business and consumed back into the system. For the purpose of these slides, the HCA platform logo here is going to refer to the stuff that is proprietary and running on our servers, and then how it interacts with other technologies. So the overview of the whole thing, projects start by taking quality control and project requirements from the client. There are specifics about their road network, their curve naming conventions, signing conventions, special reports, and a lot of parameters required by CARS to do analysis. Also, of course, we need the road network in GIS. We have some tools that pre-process client road networks to make sure that they have all the information we need for our systems and to produce the outputs, or inputs rather, that CARS requires to do its work. Those get loaded onto the platform, and step one is planning routes. Processors use special route planning views to create optimized driving routes that are handed off to collection teams. The driving is done, and the primary output of the CARS in-vehicle device are large sensor files. Those are uploaded to CARS, and our curve processing techs use our interfaces along with CARS to process curve data. Simultaneously, the video is sent to our sign reduction department, where the GPS is extracted, and sign processing technicians use the video, sign procs, and our views to reduce sign data. We have an additional challenge here because SignProx is a single user application designed to be installed at an analyst's workstation to combine the sign data from multiple SignProx installation and maintain a synchronized combined data set. So the outputs of all of these are loaded back onto the platform, and this creates a loop that gives us very low time to insight on how quickly we can act on data that has been collected. Finally, delivery is a synthesis of outputs from our system and the CARS and SignProx systems. Generally, we will produce the summary and aggregate information, and CARS and SignProx is used to generate individual elemental reports about each curve and sign assembly. So that's the top-down view. Some of the competitive advantages we discovered in this process. CARS and SignProx are the key analytical tools that all of these projects are organized around. But of course, there's a significant logistical challenge in making sure that you are achieving the work across the entire project and between both software platforms. So both offer raw bulk outputs that are primarily CSVs and database files. And the HCA platform can consume those very efficiently to create broadly scoped interfaces that let our analysts stay better in touch with the larger operational picture, and again, provide a lower time to insight to those operational managers about what's going on in the processing world. As importantly, we can detect changes in those internal interfaces and automatically apply them back into the system. So there's some advantages here to do with data management, bulk editing, and being able to apply broad changes across many, many elements at once that would not be possible otherwise. An area that obviously benefits from a holistic view of the whole project is route planning. Having everything together in one place so that our planners can see the sign progress, missing video areas, curves that require recollection, areas that are missing either of the two pieces of data, and plan really optimized routes with minimal deadheads from good hub locations has been a significant cost savings, especially in the larger geographies. Verification is always going to be a challenge with data collection like this. In the beginning, you have quite a lot of raw bulk data, reports, tables, and you need to somehow determine whether you have actually completed the work on a given center line to the client's satisfaction. So a major part of the platform is in consuming all of the raw data that we've generated and ensuring that we have actually completed the analysis across the entire network. That information is used to produce metrics and invoices as the projects go forward. Delivery is something you'll most likely be familiar with. We start with raw data, reports, images that are disorganized or aggregated incorrectly. And so there's a process of grouping, organizing, and getting the reports into a format that is more actionable out of the box for the working groups that need them. So that's an overview of our system. Thank you so much. I'll hand things back over to Jay.
So we do anticipate a new MUTCD in 2021. It may actually be 2022 now since the pandemic, but we expect the mandate for horizontal curve assessments to actually be stronger based on some conversations we've been privy to. So that being said, we want to make sure that everybody has the opportunity to do that. We want to help people get a head start on it if possible, even though the 2019 date is passed. We think the main problem or the main issue with that is there are going to be some lawsuits that for states or municipalities that haven't done their assessments at this point. Who benefits from quality accounts assessment? Cities benefit from our services. Counties, states, MPOs, engineers, and the driving public benefit from having quality accounts help with the horizontal curve assessment. So the next step is, what's the action plan? Quality Accounts is here to help anybody with any part of it. We can help you do route planning. We can help you do data collection. We can help you do the processing. We can help do the quality control. We actually have a contract with the state of Mississippi right now doing the quality control on their DYI project. So if we can help you out in any way, just please let us know and we'd be willing to go for it. If you have any questions, please give me a call. And we look forward to working with you. And if there's any additional questions, feel free to email me at J, the letter J, McComb, MCCOMB @qualityaccounts.net. Thanks for your time.